Good morning all students. In our previous lecture we have discussed about the geological cycle, types of weathering, that is physical weathering, chemical weathering, uh, factors affecting physical weathering, processes involved in chemical weathering. Okay, in this lecture we are discussing about basic terms or basic definitions. Okay, so let's start with this. The first term which we need to discuss today is void ratio. Now before going to discuss about this, what do you mean by void? So there is in soil particles there is some air or there is some blank spaces between one soil particle and other soil particles. So this blank space is known as void. Okay, so we are discussing about void ratio. Now what do you mean by void ratio? It is the ratio of volume of voids to the volume of solids. Now you guys already know that what is volume of voids and what is volume of solids. We have seen in our previous two-phase diagram figure. Okay, so volume of voids is VV, it is indicated with VV, and volume of solid is indicated with VS. So ratio of volume of void to the volume of solid is known as void ratio and it is indicated with E, small e. Next term is porosity. It is indicated with small n. It is defined as ratio of volume of voids to the total volume of soil. Now, volume of void is VV, but total volume is volume of voids plus volume of solid. Now, this volume of voids includes volume of air plus volume of water. So, total volume is equal to, as I have already shown you, volume of void plus volume of solids. Okay. Next term, that is degree of saturation. Now this degree of saturation is ratio of volume of water to the total volume of voids. Now volume of water means it is a phase where water is present in soil mass. Okay, so either that type of soil is either partially saturated or fully saturated. For partially saturated, there is some water content is available and volume of that water is known as VW. So ratio of volume of water divided by volume of solids is known as degree of saturation. Okay, fourth term, that is water content. What do you mean by water content? Water content is mass of water to the mass of solids. Now mass of water means we need to find the water content, that is what amount of water is present in soil mass. Sometimes it is asked for an engineer to find the what is the water content of soil at present. There is a different types of water content present in soil at different phases. Suppose if that soil is easily removed from soil mass, then it has some portion of water content, but when we are putting it in oven drying, oven that soil becomes dry. So due to that soil becomes dry, it loses its water content. Okay, so to find that water content, what amount of water is present in soil, we need to find the water content. Okay, what is the capacity to absorb the water of that soil? To describe it, we need to find the water content. Okay, so water content is mass of water to the mass of solids. Fourth term, that is dry unit weight of soil. Now dry unit weight of soil is ratio of weight of soil solids to the total volume. Okay, now weight of soil solid. Now what do you mean by weight of soil solid? It is only weight of soil mass. Okay, there is not an addition of air content what is present in soil mass. So we are going to discuss only about, we are going to focus about weight of soil. So weight of soil divided by total volume is known as dry unit weight. So it is dry unit weight, so there is a no interaction with water in that type of soil. Okay, this type of unit weight we can find after putting that soil in oven. Okay, fifth term, that is bulk unit weight. Now bulk unit weight of soil is ratio of total weight of soil mass per unit of total volume. Now here we are going to find the total weight. Now total weight is addition of weight of soil solids plus weight of air plus weight of water. As we know that weight of air is always zero, so weight of solid plus weight of water is total weight upon total volume, that is volume of voids plus volume of solids. Okay, next term, that is saturated unit weight. Now we know that saturated unit weight is total weight of saturated soil mass. Now what do you mean by saturated soil mass? If that soil has a water content which is available, if that soil contains a maximum water with it, what it can absorb is its saturated soil mass, okay, to the total volume. Now total volume is V. Now here we are going to find doubly saturated, that is what is its capacity to absorb the water, that is our weight of saturated soil mass upon total volume, that is volume of voids plus volume of solids, okay. Next term, that is submerged unit weight. Now submerged unit weight, as we know that it is a ratio of total weight of submerged soil mass divided by total volume. So doubly submerged upon weight, sorry, volume. Next one, that is specific gravity of soil mass. Now what do you mean by specific gravity? It is a ratio of weight of given volume of soil, that is whatever amount of whatever volume of soil mass we are going to collect from the collecting from the at certain depth by core cutter, its total volume divided by weight of that equal amount of water, okay, that volume of water in that soil mass. Suppose if we are going to take 1000 ml cube, okay, so in that 1000 ml cube, what is the weight of soil mass, okay, and it can what amount of water it can carry. So the ratio of weight of solid mass divided by weight of water, it both have the same equal volume, okay. At the equal volume, what is the weight of soil mass divided by weight of water, that is known as specific gravity, okay. It is also always indicated with G. Now the soil mass have different specific gravity. It ranges from 2.60 to 2.7. Some soils have a value around 2.20, 2.30, but it depends upon the soil mass, okay. What is the weight of soil mass divided by weight of water? Next term is, that is air content. Now air content is the ratio of volume of air to the volume of voids. Now volume of air, where it is available, it is available in only dry situations, okay. So this is not a case of for fully saturated soil. For dry soil, volume of air we can get some amount of volume of air upon total volume of voids. So Va upon Vv, that is known as air content. It is indicated by A suffix C. Next term, so many times it is asked that derive the relation between void ratio E, specific gravity G, water content W, and SR, that is space degree of saturation. So for deriving this equation, we need to again see this figure. This is our three-phase diagram figure, okay. In this figure we can see that at the bottom there is soil mass, after that there is water content, water is available, and at the top there is air present. So water has some void ratio, that is it is indicated with EW. Now total void ratio, that is E, is equal to void ratio of air plus void ratio of water. So it is indicated by small e, and the volume of solids, that is indicated with S. So total volume is Vs plus Vv. You can see this here. Uh, Total volume is volume Vv plus Vs. Now what is Vv? It is volume of voids plus, as you can see that Vs has a value of 1. So Vs is 1. So total volume will become as V plus 1. So Vv, we know that Vv is E. So total volume will become as 1 plus E. Okay. Now we know that what is degree of saturation. Degree of saturation is ratio of volume of water divided by volume of voids. So for volume of water, we can see this by figure. Volume of water is EW, that is void ratio of water, upon volume of void is E. So SR becomes EW by E. So if you find the equation of EW, it becomes as SR into E. We are showing this equation, indicating this equation by A. Now we know that water content is volume weight of water upon weight of solids, okay. So weight of water, we can find this by gamma. So gamma W into VW, okay. As we have known, we have seen that weight unit weight of water is ratio of weight of water divided by volume of water. So by this we can find VW, that is weight of water, is equal to what? gamma W into VW upon weight of solids, that is gamma S into Vs. So by this we can find this equation as gamma W and VW. Now VW is from figure, it is 1, sorry, EW, and volume of solids, that is 1. So our equation becomes gamma W into EW upon gamma S into 1. Okay, now as we have seen in previous slide, specific gravity G was indicated by gamma S upon gamma W. Now from this, putting value of G in above equation, so what will happen? W is equal to EW by EW by G. Okay, see here, gamma W by gamma S is 1 upon G, so putting this value as G, so water content becomes EW by G. So from this we are going to put the equation in the form of EW. So EW is become as a W into G. Now comparing both equation A and equation B, what will happen? From equation A we can see that EW is equal to SR into E, and from equation 2 B we can see that W into G. So by comparing, the equation becomes as E into SR is equal to W into G. So from this, if we find the equation of void ratio, it becomes as a W into G upon SR. Okay, so going for a next slide. Now this slide is shows you the relation of bulk unit weight. Okay, we need to derive the equation gamma B is equal to G plus E into SR into gamma W upon 1 plus E. Okay, we need to derive this equation. So for this we can start from gamma B. Now gamma B is equal to what? W upon V, as we have seen in previous slides. Weight of total weight of total weight of soil divided by total volume. Now total weight is equal to what? Ws plus Ww plus Wa, but air has a no weight, so Ws plus Ww upon V. So putting this equation in the form of gamma and V, Ws become as a gamma S into Vs plus gamma W into Vw upon V. So from this, if we can put again, we have equation of V, that is 1 plus E, as we have seen in previous slide, and Vs is equal to what? 1. So this equation becomes as gamma S plus gamma W into EW upon 1 plus E. See, in the second term we have seen that gamma S plus gamma W into EW upon 1 plus E. Now we know that specific gravity G is the ratio of gamma S upon gamma W. Okay, so from this gamma S becomes G into gamma W. In third term you can see this G into gamma W plus gamma W into EW upon 1 plus E. Okay, so from this G plus EW we can put common values, that is gamma W we are getting it away from this equation, so it becomes G plus EW into gamma W upon 1 plus E. So this is our equation. You can see this EW is what? EW is equal to E into SR. Okay, so our final equation becomes as a gamma B is equal to G into G plus E into SR into gamma W upon 1 plus E. Okay, the final derivation of this chapter is derivation of gamma D, that is dry unit weight is equal to what? Gamma B upon 1 plus W. Okay, we need to derive this equation. Now we know that water content is equal to WW upon WD. Now that is weight of water upon dry weight of water, dry weight of soil mass. Okay, uh, putting both side by adding both side with 1, so equation becomes 1 plus W is equal to 1 plus WW upon WD. So 1 plus W, this term, see, you can see this 1 plus W is equal to what will happen here? WD will multiply with 1, so equation becomes as a WD plus WW upon WD. Okay, now we know that WD, that is dry weight plus weight of water, is equal to total weight, so we can replace it with capital W. So our equation becomes 1 plus W is equal to W upon WD. Now we are going to make the equation in the form of gamma WD. So WD is equal to what? W upon 1 plus E, dividing both sides with volume. So WD upon V is equal to what? W upon V into 1 plus W. Now we know that WD, that is dry weight upon volume, is equal to dry unit weight of soil. So gamma D is equal to what? Capital W by capital V is indicated by gamma B, that is bulk unit weight. So bulk unit weight upon 1 plus W. So this is our final equation. Sometimes it is asked in GTU exams. So gamma D, that is dry unit weight of soil, is equal to uh, bulk unit weight of soil upon 1 plus water content. This is our final equation. Okay, for the if you students have any queries regarding these derivations, you can comment me in comment section, or else you can ask me by mail also. Okay, so this is the end of our lecture. Thank you.